So the conceptual modeling of the data warehouse. When we model the data warehouse, there are several concepts for the modeling. We need to see the modeling of the data warehouse from the aspect of dimensions and the measures. So first, about the dimension and measures with the star schema. So it is a fact table in the middle connected to a set of dimensions. So we will see later what is the meaning by the dimension table. We have another concept, we call it Snowflake schema. Snowflake schema means a refinement of star schema where some dimensional hierarchy is normalized into a set of smaller dimension tables. So if you know about Snowflake, so it's like a snowflake, that's why they call it the Snowflake schema. And the other kind of model, we call it fact constellations. There will be multiple fact tables, shared dimension tables. And then it is viewed as a collection of stars, therefore called as galaxy schema or fact constellation. So let's see the example. We call this is the star schema. We have fact table. Fact table, it will be in the middle. Let's say we have the sales table. Okay. The sales table that we extracted before. Okay. So we have the sales table like this one. It is extracted from multiple tables. So we can make it as a fact table like this. So we call it, this is the sales fact table. And for every of this attribute, it will be extracted from your table. We can see the time. It is from the time table. For the item, we have only the item key. So the item key will be extracted from the item table. We have branch key. So the branch key, it will be connected to the branch table, and so on. And we will have the measures. So the measures is the combination between all the dimensions. So we call this is dimension table, dimension table, dimension table, and dimension table. So this is the example of the star schema. We have, based on the definition, a fact table is in the middle, connected to a set of dimension tables. What about the Snowflake schema? In the Snowflake schema, it is more about the snowflake. Okay, if you look at the snowflake, we have a dimension table connected to the sales fact table, and for every of this dimension table, there will be another sub-dimensional table. So for example, for this item, I have the item key and then item name, brand, type, and then I have the supplier key. So the supplier key will be connected to another table, which is about the supplier. Then, in this case, yeah, we have another sub-dimensional table. Yeah, this idea is still similar with the star schema, but it is more detailed, or it is more in the more relations with the other table that is connected to the dimensional table. So you can see the concept like this one. We have the dimension tables, and the dimension tables can have many sub-dimensional tables. because this is the Snowflake schema. We can have fact constellation. So the fact constellation is a combination of multiple fact tables. When we have the sales fact table, we might combine with the shipping fact table. So if we want to model into the data warehouse, we need to combine those two fact tables, and those two fact tables will be connected to all other dimensional tables. So all other dimensional tables are connected to the more than one fact table. So in this case, the sales are connected to the time, brands, item, and location. Meanwhile, the shipping is also connected to time, item, and location, but not with the brands, because there is no relation with the brands after the sales occurs. So the shipping, we just need to connect with another key, which is the shipper. So there will be another dimensional table. We call this is the fact constellation. And usually in the data warehouse, we will see this fact constellation because you have a lot of data and you need to build your data warehouse with many facts. As you might know, the data transformation contains the concept of hierarchy. So we can also see this kind of data warehouse with this concept of hierarchy. When you have some data, let's say location, so the dimension or the location, you can put it as a hierarchy. Let's say the first is all countries. And then you can separate it into some regions like the Europe and North America. And then you can distinguish each of the continent into the countries, Germany and Spain, Canada and Mexico. And then you can distinguish those into the smaller concept, which is the city. And you can put the details. Let's say I want to know where is the office is located. So the detail like this one, we can it as the concept hierarchy for the dimension location. If you have this kind of dimension, you can represent it with the one that we already learned, the concept of hierarchy. So the data cube measures, if you look at the measures before, these are the measures. Okay. These are the measures. Unit sold, dollar sold, average sales. We have dollar cost, unit shipped. So those are measures, and we want to check the measures. And usually the data warehouse will contain three kind of categories of the measures. So the first is distributive, the second is algebraic, and the third is holistic. Distributive. Distributive means if the result derived by applying the function to an aggregate value is the same that derived by applying function on all data with top partition. Maybe it's a little bit complex to understand these words, okay? But the simple way is we just want to do the function, okay? Count how many items of the data. We want to see the summation. We want to see the minimum. We want to see the maximum. So this is the function of the distributive. So we want to just know the distribution. For the algebraic, if it can be computed by an algebraic function with m arguments, it means the m is a bounded integer, each of which is obtained by applying a distributive aggregate function. So usually this algebraic function will be a function after we extract the distributive. For example, if you want to know the average, when you want to get the average, it means it is the function of summation divided by the count. If you want to know the standard deviation, it means for every of the item, it will be subtracted with the average, and then let's say you have xi, you will extract it with the average, which is x bar, and then you will do the square, and then you will do this summation. After that, you will do the square root, and then at the end, you will divide it with the number of the data. So this is the meaning by the algebraic function. You will get those from the distributive function. The other one is heuristics. In the heuristics, if there is no constant found on the storage size needed to describe the sub-aggregate. So this kind of function can be about like the median. So if you want to check the median, you need to sort the data. After you sort the data, then you will check what is the middle value. If you want to see the mode, so you need to check for every single categorical data. If you want to put the rank, so the rank, there will be some functions on the rank. Okay. So this is what we call as the holistic measures. So let's say if I have like this data, row 1, row 2, row 3, row 4, and C1, column 1, column 2, and column 3. Then I can find the very basic, this is the distributive, and this will be the algebraic function, because I can get this average based on the count, and I can do also the sum. I don't put the sum here. So the average will be the sum divided by the count. We will get the average is 2. And then we have this data like 4, NA, and 6. So the minimum is 4. And we can see the data, there are 2 because 1 is NA. It is not available. And then if we want to see the average, it is 10 divided by 2, then we have 5. And if we want to get the median, it is 5. And so on. So those measures are based on the row. And these measures are based on the column. So whenever we use the data warehouse, we can create these data cube measures in these 3 categories. This is one example. I think this is an old software. I just want to show you. This is from one software called BB Miner. You can have the schema hierarchy with a tree. So the schema hierarchy with a tree, you can see like this one. If I have the office, okay, I want to know which office that I want to explore. So the higher concept is city, the higher is country, region, and all. It means for the first part is any. And then you can click to check the details. In here we have Europe, we have Far East, we have North America. If you click again in Europe, you can see there are many countries in Europe like Belgium, France, Germany. If you click on Germany, there will be the two cities like Essen and Frankfurt. Maybe if you want to check the details in the North America, in Canada, there are some offices in the Vancouver. The first office is the Charles Lunam, and the other is Harry Crane, Kelly, Gretchen, Lee Chan, Malcolm Young, and so on. So we got this is the hierarchies in the data warehouse, and we can use the view concept in the data warehouse. And if you look at the data warehouse with the data cube, usually it will be represented as the multi-dimensional data. As you already know, when we are using this multi-dimensional data, for example, with the sales volume, we can see this is a function of product and time. Let's say this is a month, and we can have also ratio. So this is the very common approach for this sales. We have the dimension, which is product, location, and time. Product, location, and time. So the product itself, we can have the hierarchy. What is the product? Maybe the product is laptop. The product is PC, personal computer. So they are in the category of the electronic products. And if we know the category, then we can see the industry type. So this is the first hierarchy. Hierarchy in the respective of the product. We can also have another hierarchy, the hierarchy in the respective of the office. And we can also have another hierarchy, the hierarchy in the respective of the time. So every of these will have their own hierarchies. So this we call it as the multi-dimensional data. And this is the hierarchical summarization heads. And you already learned about the data cube. Okay? When you get the data cube, so you will just see for every cube here. So the cube can be represented as the sum. Let's say I have the product TV, PC, VCR, so with video recorder tool, and then I want to check this on the first quarter, second quarter, third quarter, and fourth quarter. And I have the country, which is the USA and Canada and Mexico. So you can do the summation based on the every dimension. Let's say this dimension, it means you want to do the summation of the first quarter. If you want to see this summation, it is the summation of the TV. If you want to see this summation, it means this is the summation based on the country. And if you want to see the all summation, then you will see in this blue color. Every cuboids that we learned before, it is corresponding to the cube. So every cuboids, it will be represented in the cube. So every cube here, it will be in the cuboids. So let's say if I have this cuboid, okay, so let me explain again the apex and the base. So the apex means for all of the attributes, and the base is representing for the 3-dimension. Let's see this one, we have 3-dimension. Okay. So the apex is just 0-dimension. If we are dealing with the 1-dimension cuboids, so we will just check on the one attribute. If we have 2D cuboids, it means we will deal with the 2-dimensional attributes. If we have 3D, then we will have the 3-dimensional attributes. So every of these cuboid, it can be represented in the cube. So I will just review a little bit what you already learned in the previous chapters. We learned about the roll up. We learned about drill down. So I will add more operations on the OLAP. So there are at least 4 operations that you need to know. I guess you already know the roll up. Roll up or drill up, it is to summarize the data. It means we can climb up hierarchy or by dimension reduction. Drill down or roll down, it will reverse of the roll up. It means we want to go down after the higher level summary to the lower level summary, or we want to make a detailed data. So we can introduce new dimension as well. There will be another operation, we call it slice and dice. So we can project and select and pivot or rotate. This is to reorient the cube, or we can make the visualization, or we want to make from the 3-dimension to 2 dimensions. Because in the cuboids, in the cuboids concept here, we can have 3-dimension, we can have 2 dimensions, we can have 1 dimensions. So there will be slice and dice, and there will be another operation, we call it pivot. Other operations we can use like drill across, it involving across more than one fact table, or we can drill through the bottom level of the cube to its backend relational table using the SQL. So let's see one by one about this operation. I guess you already know the drill up, drill down, roll up or roll down. So if it is the roll up, I have cities, Florence, Venice, Nice, Lyon. So the Lyon and Nice, they are in the country of France. Venice and Florence, they are in the country of Italy. So we want to roll up from the location, which is cities, to countries. If you want to drill down, okay, or roll down, let's say I have the sales on winter time, springtime, summertime, and fall. So I can roll it. I can drill down or I can roll down to the months October, November, and December. Let's say for the winter and spring. Yeah, let's say I have the January, February, March, and then summer. Let's say I have this July, August, September, and oh, so summer. I can say maybe this is in the okay. Anyway, we can change to quarters to months. Okay, maybe the month is not representing clearly, but we know that maybe your winter is from December, January, February. Yeah, it can be break down into the months. Slice and dice. What does it mean? If I want to slice the data from this cube, I want to check only on the winter time. So yeah, I can slice on this part. Okay. So the part, this part will be our analysis because we just want to see on the winter time. Or let's say I want to dice. Okay. So dice means if we have this kind of cube, we can slice into a row wise, or we can dice into the color wise. So the dice means we can just select only a particular cube. Let's say in this case I have the location. I want to see the location which is Venice or Florence, and the season is winter or spring, and the item is the component or clothing. So usually we need to develop this kind of SQL. So this kind of SQL will give you a dice. We call this is F dice. Pivoting. So when we do it, the pivot means we want to change our orientation of the analysis. So here I have the first orientation is about the city. And I can see that the mobile, modem, phone, and security is in the X, and then the city is in the Y. So I can do pivoting. So the pivoting means change the orientation from X to Y and from Y to X. Now maybe this is just one very simple example, but you can also see in the orange using the pivoting, and in the pivoting on the orange, you will make the summary or you will calculate. So we will take a look later with some examples. The other examples is this one. If we want to drill across, here I have a product 1, we have 40, and I have product 2, we have 52, and it is a sales in 2017. So I can drill across because maybe I don't have any details on the client. I just have the product, item, and the countries. So we can get drill across by using the SQL to find the client. So the product 1, let's say it is 5 in the client 1, and then it is 35 in the client 2. So we use this attribute, which is not available in the attribute, but it is in the other kind of attributes, because this is drill cross. And we can drill through summary report to a detailed report showing the revenue break up by product line. Let's say this one, it is drilled through. We can see this is the America. This is the sales in the Americas. When we can see this revenue on Americas, we can also see this revenue in the respective of the product. So in the Americas, I want to see what kind of products are available or are the sales in the Americas. And yeah, we can have this detail. So we call this is the drill through summary report. The other kind of query, we call it, this is the StarNet query models. In the data warehouse, I think this is the most important part, or this is the most complicated model. And yeah, it is one of the model that usually a big company use because it represents from the every aspects. Let's say in the customer orders, I can see the contracts, or maybe without contracts, the customer can directly order. And there will be another table or another dimension, we call it customer. And for the product itself, there can be some kind of the detail, we call it the product item. And then the next will be the product line. And we can see based on the product group. If we look at the organization, the detail is the salesperson, and for every salesperson, it will be located in their own district, and there can be a division. So it is like the hierarchy. Let me skip the promotion. Let's see the location. So we have the city, and then country, and then region. And what about the time? Okay, I can see it is in the daily or quarterly or annually. And what are the shipping method? So the shipping method, they distinguish into the different shipping method like the truck and air express. So let's say if I want to see my data in the data warehouse, I can make this StarNet query model. This is the StarNet model, and then I can make the query. I want to check based on the contracts, on the product group, on particular districts in the respective country, and the time is quarterly. Then it will be easier for you to extract the data, and you can do the analysis based on this query. With the visualization, well, we can browse a data cube. So this is an example in one data warehouse. So with this data cube, you can see that, okay, this data is more other than the other data. So let's say if I want to check this data because it has more, maybe in the terms of frequency or in terms of sales, and this also is more because it shows bigger than the others. Then you can focus on the bigger cube only. And then you can see the OLAP capabilities. Let's say I want to slice, okay, or you want to make a dice. So you will just put some conditions on the query. If the size of the cube is bigger than some condition, then you want to extract it. And there will be some interactive manipulations also. Okay, so just simple learning check. How many dimensions are there in the data warehouse? We learn at least 3. We have star, schema, we have Snowflake, schema, and we have the fact constellation. There is another, we call it a starnet query mode. So those are the dimensions in the data warehouse. How many methods are there in the data warehouse? In the data warehouse, we have the methods, the distributive, and then we have the algebraic, and we have the holistic. So those are the methods. Can you mention the typical OLAP operations? So you already know we have drill down, okay, or drill roll down, or we have roll up, and then we have pivot, we have slice and dice, we have drill through, we have drill across. Okay, so those are some of the operations in the OLAP. Okay, I think it's the time to finish. Any questions or comments?